This is TWiT.
Chrome, fortunately, will be getting tough on abusive ads. In a posting on GitHub, Google's engineer John Delaney has spelled out the Chromium project's intentions regarding abusive ads. So, first of all, modern web pages are a jungle of stuff. So how does Chromium, the Chromium engine, determine for itself what's an ad and what isn't? It comes down to something known as ad tagging. Chromium is able to detect some ads and the resources they load in the browser. This enables the browser to measure the size, the performance, and the count of ads displayed to its users. It also allows the browser to intervene on the user's behalf when ads run counter to what they decide is the user's interest. For example, using a crazy amount of resources, engaging in some abusive behavior, or whatever. So the ad detection infrastructure they call ad tagging, and it's not very inspired. It works by matching resource requests against a filter list to determine if they're ad requests. And in a sample that they've got of some code, they show them importing the easy list, which of course is a well-known list that's being maintained by a community of known domain names that are providing ads. So they said any requests matching the filter are tagged as ads. Further, requests and some DOM elements, such as iframes, made on behalf of previously tagged scripts are also tagged as ads by the ad tracker. So it's not just images that match the filter. It's if scripts were coming from a known ad source, then things that are essentially descendants of those scripts would also be tagged as ads, which certainly you'd want to have happen. They said an iframe will be marked as an ad iframe if its URL matches the filter list, if tagged script is involved in the creation of the iframe, or if its parent frame is an ad iframe. So, you can't sneak out of it by creating a frame within a frame and say, oh, look, I'm not the original one. The main frame on a page will never be tagged as an ad, good. And then they said any request made within an ad iframe is considered an ad resource request. So drilling down on this one level, we learned that the sub-resource filter loads the filter list and then performs this URL matching of any requests against that list. It's distributed, that is, the filter list is distributed via the component updater, which is just part of the Chrome installation. So it's being kept current constantly. And the same list and component is also used for blocking ads on abusive sites and those that violate the Better Ads standard. They explained that each sub-resource request in the render process is processed by the sub-resource filter before the request is sent from the browser out. So it's not that it blocks things coming back. It never makes the request in the first place. It just, denies it on the, from the page making the request. Okay, so you get ads identified as such. How are they treated differently? This is where John explains what they call the heavy ad intervention. A small fraction of ads on the web use, and John likes the word egregious, we'll see this a couple times, an egregious amount of system resources. He says these poorly performant ads, whether intentional or not, harm the user's browsing experience by making pages slow, draining the device's battery, and consuming mobile data. He says for those without unlimited plans. And then he says in these egregious cases, the browser can upload the offending ads to protect the individual's device. I'm sorry, the browser can unload. I was saying, what? The browser can unload the offending ads to protect the individual's device resources. He says this is a strong intervention that's meant to safeguard the user's resources with low risk because unloading an ad is unlikely to result in loss of functionality of the page's main content. He says examples of observed ad behavior that are intended to be discouraged are, no surprise, ads that mine cryptocurrency, ads that load large, poorly compressed images, so just sloppy ads that load large video files before a user gesture, or ads that perform expensive operations in JavaScript, such as decoding video files or performing CPU timing attacks. Yeah, we don't want those. So Google notes that it's not their intention to discourage any specific ad creative formats, such as display video ads. So they're trying to be as agnostic as possible. So the user agent, the browser, will unload ads that use, and he says again, an egregious amount of network bandwidth or CPU usage. We define egregious as using more of a resource than 99.9% of ads as measured by the browser. So that sets a very high bar. He says only ads that have not been interacted with by the user will be unloaded. And here's what's interesting, and this is some tech we've never talked about before, that's therefore worth mentioning. All unloaded frames will be notified via an intervention report that the intervention occurred. This feedback is necessary to help advertisers or their ad technology vendors to identify and fix ads that are triggering this intervention. So, first of all, just a little last word on the classification of ads. He says that's left to the discretion of the user agent. For example, Chrome detects ads using what we talked about, the ad tagging feature. An advertisement is considered heavy if it has not been clicked on by the user and meets any of the following criteria. It uses the main thread for more than 60 seconds total. Or used the main thread for more than 15 seconds in any 30-second window. So they said in parentheses 50% utilization over 30 seconds. Or used more than 4 megabytes of network bandwidth to load resources. So any of those thresholds get crossed. The new Chrome technology will say nope and just boot the ad. It's, sorry, you're a bad ad. And he said that the thresholds above were inspired by the IAB's lean standard, that's in caps, but is chosen by looking at Chrome's metrics at the 99.9th percentile of network and CPU usage in ads. So again, most ads are not going to cross that line, but those that do, and there are some, bye-bye. He said the threshold numbers were then rounded to be readable and memorable, thus 60 seconds instead of whatever it actually was, or 15 seconds in any 30-second window, and so forth, and 4 megabytes. Numbers were picked inclusive of all ads seen by Chrome's ad tagging, which is better at capturing display ads than native ads. When these interventions were put in place, they wrote that intervening at those thresholds saves 12.8% of the network usage by ad creatives and 16.1% of all CPU usage by ad creatives, with most of that value going to individual users, meaning individual sources. So that's interesting. That means that despite setting the bar that high so that it is at the 99.9th percentile, it creates a savings of 12.8% in network usage and 16.1% of across the board in CPU usage, which suggests that what is actually happening is a very small percentage of ads is trying to use a really obscene, I mean, I'll use that word rather than egregious, an obscene amount of network and CPU. So this seems like a really good thing to do. You put the bar really high and you say to a very small percentage of really extremely misbehaving ads, bad. We're kicking you out. You can't do this anymore. So this one concept we never talked about, this so-called intervention report, is a very cool extension of the web API, which essentially allows closing the loop. Modern web browsers support what's known as the reporting API, which allows them to send back asynchronous event reports to a resources sourcing server, or at least the server that they have said they would like to have receive those reports. So as we know, a web page or code on a web page will make a query to a remote web server for content. And that content might be an advertisement. One of the headers in that remote web server's reply can be report-to, report to. Its corresponding string value is a JSON formatted string to which contains a URL and an expires tag, to which reports of any subsequent issues with that resource can be sent at any later time, subject to the recipient's requested expiration. So, for example, if JavaScript were to crash, which had been received from that source, a report can be sent back to the source saying, hey, your JavaScript crashed. Or in this case, if an ad has misbehaved such that it has been unloaded from the browser, Chromium-based browsers will, if there is a report to header that accompanied the ad, will play nice and say, hey, thought you should know this ad has been booted. So you ought to consider maybe doing something different, like compressing the image or shortening the video or stop trying to mine cryptocurrency or whatever. So anyway, just a very cool sort of next step in the evolution of the net. It's one of the things that's nice about the way the net works is because it is this relatively clean query and reply, or request and reply structure. It is simple to carefully, we don't want to overdo it, but to carefully add additional high value features which can further mature the web side of the internet, and this is certainly one of those. There is a fun way for our users to play with this stuff. For anyone who has Chrome 84 or later, which should be everybody because we're all at 85 now, there are a couple flags which are not yet enabled by default. Google will be, this is like their statement of what we intend to do, but the tech already exists since Chrome 84. If you go to Chrome : in the URL bar, Chrome : //flags/ and then pound enable -heavy -add -interventions. You can turn this on. And then also there's another one in there, heavy add privacy mitigations and that one is also hyphenated. Setting the Chrome flags enable heavy add intervention will activate this behavior, but they recognize that because behavior could be probed by somebody deliberately trying to figure out where the triggers were. And that could also be a privacy problem, that the so-called privacy mitigations deliberately add some fuzz to the thresholds. So if you want to turn that off, you can turn that off. Shoot, and there was I had another piece of this that didn't make it into the show notes, because there's a site you can go to that deliberately misbehaves. And so you can see this all happening, but I forgot to transcribe it into the show notes. So I will provide it next week in the errata. I meant to do that because it was a place you could turn this stuff on and then go there, and it was like a, as I said, a deliberately misbehaving site that was kind of cool. So nice that our browsers are getting that. I thought it was really interesting that setting the bar that high created that large a savings for the typical user. So there are very few bad actors, but boy, they are really bad. And now they're going to get caught and told, sorry, you don't get to do that anymore.